time series is a collection of observations made over a specific period of time, whereas time series forecasting is the process of analyzing time series data using statistical data and modeling to make prediction and instruct rational decisions. It is a method for forecasting future events by analyzing past trends with the expectation that future developments will be similar to the historical trends. Despite the fact that the time series forecasting has the capacity to change businesses' model and enhance profitability, many companies have yet to embrace it and reap the benefits. In this course, we will break down the multivariate time series forecasting for the COVID-19 first wave. So let's get started right away.
So let's start. We are going to do a forecasting on first wave of COVID-19. But before that, I would like to share my motto. It is not actually my motto. I follow on this motto from Ronald Coase. If you torture the data long enough, it will confess to anything or everything. That's anywhere, whether you have classification, regression, time series, everywhere, but time series, it is little less, and deep learning also everywhere. That's it. So spend time with data, understand the data, get feel of it, and then it's something like that. You are going to marry. If you don't know that person, you don't understand that person, your relationship will not long last, right? So that's the thing, that you are going to marry the data. Be like this. You guys are data scientists. If you are going to transition or you are going to work, this should be your motto. This should be your mantra. Okay, so what is time series forecasting? First, who don't know time series, let me just give you a brief about what do you mean by time series. Till now, you guys have been working on classification and regression problem on a structured data, which is time independent. Time independent as in, like if I'm doing a prediction, whether I have to grant loan, I mean, this person will default on loan or not. Just simple example I'm taking from your Python for data science, that basic one. If you have to predict that India will win the World Cup or not, this T20 World Cup or not, you have to predict yes or no, or which country will win it. That's what you have to do. So all these are on time independent data, means you're not having a sequence of time over there. But when I have to do a weather forecasting, tomorrow's temperature, today's temperature, yesterday's temperature, all are in a time flow. They're time dependent. Tomorrow's temperature will depend on today's. Today's is depending on yesterday. There is some linkage. So when you have a series of data on a regular time interval where time plays a significant role, that is time series. When you do a remember there are two words in data science. One is prediction, other is forecasting. Always, people make this mistake. Always, guys, time series is a forecasting. It is not prediction. Prediction could be done on time series, but when you are using machine learning regression models, otherwise it is forecasting. What happens is, when you are doing time series, you are forecasting. You can forecast for the period of 20 days, 10 days, 1 month, 1 year, whatever it is. You can do the forecasting without any input. You are going to do whatever is the previous value. Based on that, I'm going to foresee the future for a good amount of time frame. That is forecasting. So that's what is the difference, which people don't understand and they mess up in their interview. Be very clear on that, guys. So let's see what are the steps. First is always to define the problem. What is your problem? How you are going to tackle it. Second is prepare the data. Prepare the data means when you are working on a time series data, it has to be in date. Your index should be in date and time format. I'll show you all these things. You should have it on a regular interval. It shouldn't be, suppose I am forecasting sales of any a brand, let's say any supermarket sales I am going to predict. What I want is, if I am collecting the data regularly, it should be regular. There shouldn't be any break. Or if it is say monthly, it should be Jan, Feb, March, April, like that. It can't be Jan, then March, then suddenly July. No, it has to be regular interval and in sequence. Then only time series is there. In machine learning data set models which you create on the data set, over there sequencing doesn't matter. It is random. But in time series, sequencing is the key. This I am emphasizing, many of you would know, but I am emphasizing for the people who haven't gone to time series module till now. Analyze, of course, that is everything. Analyze whether you have trend or seasonality in the data. I'll explain this thing, don't worry. Model it. You have statistical models in time series. You have to model it out, then deploy it in production, and you have to monitor how your model is behaving. Overall, this is the complete picture that we have in time series or anywhere that you have. Just the difference over here is the step number 2, where you have to prepare the data monthly, quarterly, yearly, whatever it is. Remember one thing, whenever, not just in time series I'm talking about, whenever you are working on any data science problem, this is the basic assumption on which data science works. What is that assumption? That you will pattern out things on previous data, past data, or historical data, right? Whatever name you want to call it. On historical data, you understand the pattern, and then you predict or forecast for the future, right? Based on that pattern only, it does that thing, based on the input value, whatever you are doing prediction or forecasting. So what we believe is that my future, whatever is the future, it is approximately similar, it has approximately similar behavior to my past or historical. It is not changing abruptly. If that happens, your model goes for the toss. That happened during COVID situation. Every company will forecast their sales, they will forecast their demand, inventory, all these things would be forecasted for them. And with that forecasting, what happens is that they are assuming, let's say they if you guys know this thing, that before this lockdown in 2020, what happened is every company did the forecasting and all that. They will be manufacturing according to that. This car companies did a lot of manufacturing, but with sudden lockdown, now this is an abrupt change. Your future situation and your historical situation is totally different. It was not anticipated. So with that, what happened? Lot of cars were dumped like that only. After lockdown opened, cars were sold at a lower price, means a discount of 3 lakh, 2 lakh, 2.5 lakhs were given on top models also, because they just want to get rid of it to get back some money. This is how the model went topsy-turvy. And when that happens, it will definitely create a chaos, because now your system is not in place. So moving ahead, we are going to do multivariate time series forecasting for COVID-19 first wave. I have a global data for all the countries based on confirmed cases, recovered, and fatalities. So we will look at the confirmed cases, how to predict it as a univariate, and then we will combine recovered with that, so that we can do the prediction for multivariate also. Okay, multivariate time series. Now, what's the business objective of COVID-19 first wave? We will take India as the case study. You can do for other countries also, but we are going to take India over here. How it will help? It, since first wave gone, second wave also gone, and now we are saying the third wave might come. But let's assume that we are in 2020 only, and how it will help? It can help your medical association, it can help your government to take better actions, better planning should be done, and they can do a lot more to reduce the cases or to take better course of action, so that if cases also come, they are recovered, fatalities are reduced. That's where I think so Indian government missed out. They didn't do this analysis that they should have come. We should have done this before for them, right? Anyhow, who will get benefited from this forecast? So of course, government will get benefited, your population will get benefited, everybody will get benefited, because this one is really something which is concerning. What actions can be taken to stop the increasing impact? Government can come up with new hospitals. Government can take strict measures, like they opened up all these restaurants and everything. They can do this thing, right? They can control this. Of course, everything is not in government hand. It is in human. We people also should do this thing. So if this forecast is done, it should be projected for news agencies, news channels, and with that, what would have happened? It would have increase the awareness in the people. At least if not 100%, 50%, 60% would have been aware, and this chaos of second wave wouldn't have been created. Country, latitude, longitude, province, and all these things, all different countries, global cases I am having, how many cases were reported. Similarly, I have for recovered also, and similarly I have for fatalities also. So these are the 3 data sets. Now, of course, if you have more confirmed cases, more people will recover. If you have more confirmed cases. Deaths could also be more. That is also something possibility. But yes, they are interlinked. So this becomes as a multivariate time. We can create as a multivariate time series. We are linking everything and trying to predict. They would be having impact on one another. So we will see it as an exogenous variable as well as multivariate. So time series data modeling, when you are working on time series, some basic models that you have is naive method, ARIMA, which is autoregressive integrated moving average, and we will learn about its variation, exponential smoothing and its variation. These are all, what are these? These are your stats model, or these are your typical time series model. Also, time series you can handle through regression model also, where I will show you a neural net model, which is MLP, multi-layer perceptron. This is an additional model which you have not covered anywhere, but it is something similar to your ANN. I will use keras over here. So I'm combining multiple things, ANN along with your keras, and we will use it for time series. This you might not be able to get in one go, but as I said, keep this notebook with you. You practice it, you will get to this. Now, when you have to do model validation could be done by, you need test, train and test split, right? So train and test split is random when you work on classification and regression. But what happens is when you are doing time series, it needs to be sequenced. A sequence should not be broken down. And this is one part. Apart from that, when you are doing validation, we can do walk forward validation. Other name for that is rolling validation also, or rolling window validation. Then you have multi-step ahead prediction technique, where we will see recursive, direct, and memo, and also demo also I have put direct input. Okay. And walk forward validation, how we will check the performance, that is MSE, RMSE, and MAPE value. So these are the things that we will look at. I have put this thing, I'll go through this part later. I just put it over here. This is true for classification, regression, time series, everything. Bias variance trade-off, that is overfitting and underfitting. So I have something extra in store. Based on the time, I'll go through that. Otherwise, it is pretty much written in this notebook. You guys can go through that. Now let's start with the time series. As I told you, change of temperature throughout the day, week, month, or year. It is time series. Change in value of stock market or asset over time series. Change in performance of network, traffic over network, disease over time, like COVID. All these are what? They are your time series. Like, see, this is your time series. This is again a time series. Human life, your life events. These are all time series that you are having. This is what heart rate, your ECG, and all that you get. It is a time series that you have. Now, how is time series problem different from ML problem? So we have two types of time series. One is regular time series. Second one is the irregular time series. Regular time series is if the data is collected at a regular time interval. Irregular time series is the data is irregular. That we won't be using for modeling, like your ATM transaction. You have to handle that first, make it regular, and then you should use it. Now, coming to univariate and multivariate, this is where the confusion lies. Univariate is when single variable changes over time. It's called univariate time series. Like if I am just predicting confirmed cases, or not predicting, I would say forecasting. I have also started using this changeable, sorry. So forecasting, if you are doing only on the confirmed cases, this is univariate. If when two or more variables change over the same time interval, like confirmed, recovered. So it is becoming a multivariate time series. A multivariate time series can be decomposed into various univariate. I can forecast individually for confirmed also and my recovered also, but that interaction won't be there. That's why we try to do it as a multivariate. Okay. This is another thing which I want to bring to your notice, guys. Very important to understand this terminology. These are few of the interview questions that you have. Parametric and non-parametric. What do you mean by this? So time series analysis comprises methods of analyzing time series data in order to extract meaningful statistics over characteristic of time. Time series analysis techniques are broadly classified as parametric and non-parametric technique. Interview question, guys, make a note of it. The underlying stationary stochastic process has a certain structure which can be described using a small number of parameters. In short, I'm assuming some distribution for my data. When your distribution, this is basically where your time series stats model like ARIMA and exponential smoothing all come into picture. But when you don't have to assume any pattern in your data, then that becomes non-parametric. And this is something where I will be using MLP or neural networks you can use. It will give you a good result compared to your time series model. It is not like this that on time series, I have to use ARIMA and all that. People assume this thing, but those are time series statistical model. What we want is we want to have a good forecast, and that's where you can use regression models or neural network also. Okay, forecast and backcast temperature is a univariate or multivariate. Okay, so temperature, if you are doing just one over the time, whether you are doing it in ahead prediction or previous one, it would be univariate only. More than one dependent variables varying on different time intervals, do we bring them to the same time scale and apply multivariate time series? If you have data and you can bring them back to the same time scale, then yes, you can apply multivariate. Otherwise, both are specific univariate. So you can do resampling or you can do down sampling if that happens to bring them on the same scale. Terminology that you have, few of the terminologies in time series that also I have mentioned. We will talk about all these things in detail. Python libraries I have listed down. This is the pipeline. Let's quickly go over through this thing before I start the code. So data pre-processing and analysis. But of course, this analytics or any EDA comprises 80%, and then you will 20% is the modeling. But in time series, this is slightly different. The steps are slightly different. First thing that you need to do is change the date time format from string to date type. Otherwise, it won't work. It is incorrect. Check for null, missing values or corrupt values. Of course, this you will do because missing values, if there, you can't delete it because sequence will get tampered and then it won't be time series. So you want to treat it. I'll come to that, how to treat that. Uniformity of time series, you can resample it if required. Downsampling is never suggestible, but there is some technique known as downsampling also. Filter, group, and join the data if you have with any other data set. This is what we will see. Data visualization, check for outliers and abrupt changes. Perform a seasonal decompose. That's where we will get different decomposition of time series. Again, I'll speak about this. Check the stationarity of the time series using, there are two tests which you guys would have known of, ADF and KPSS test. There's one more test. I'm not going to perform this, but good to know, read about this. Hurst exponent test. Okay, this is also to check the stationarity. Sometimes it comes an interview question. Auto correlation and partial auto correlation, which is ACF and PACF that we have. We will see the plots for that. It is basically important for all your ARIMA models or its variants. Correlation study between the variables to see how much they are correlated. Then we will do model building and calibration, model validation and testing. How to treat the missing value? Missing value you have to treat, these are the most of the ones which are used in industry. Forward fill, rolling mean fill, absolute function replaced with zero, backfill only acceptable in few situations. So this is something which is pretty much understandable. Let's start. First thing what I'm going to do is, of course, this is your filter warning. So so that warnings are no more there. Load the data using Panda. So these are my 3 data sets that I have loaded. You guys are pretty much aware of it. I'm just seeing the data sets. So confirm all the head of all the data sets that I have, 3 data sets. This is what I have, which I showed you. Now I will see based on country and region, what is the value count. If you see, China is having most of them, 33, followed by Canada, France, so on and so forth. But what we will do is, we will take India only. Before that, as I was talking about train and test split, when you're working on machine learning model, you use random state to do a train and test split. But over here, you can't do this thing. You have to have a sequence in data. So what you will say, suppose you have 36 months of data and you are doing 70 and 30 test splits. So whatever is the time frame, which covers 70% of the data from the start till that 70% in sequence you will take, and rest will go to test. You can do a split of 50-50 also, 70-30, 80-20 also, 60-40 also. 50-50 is not that much entertained, but yes, you can do. So the one train test split is this. Second is multiple train test split. What we are doing is within the train, I'm just, let's say I have 5 data points. First data point I'm making training, second I'm making testing. Then I will combine this over here, training, and this one will go, next one will go as test. Like this, I am having different testing. This is known as multiple train test split. This is also one of the way to do this train test split. Important method, or this is something that is always used in the industry, walk forward validation. It is there is also other names given to that: walk forward testing, rolling forecast, rolling window analysis. All these things are done. What we do over here is we take a expanding window or a sliding window as we retrain. Starting at the beginning of the time series, the minimum number of samples in the window is used to train the model. The model makes the prediction for the next time step. Only one next time step it will do. The prediction is stored or evaluated against the known value. Because you have already the known value, you will check how it is. The window is expanded to include that known value. This is something like this only. It is some, just understand this thing. This one I did. Now I am doing a prediction based on this for one value. Now I'll compare this known value is included over here. Next one, I do the prediction. That's how is the walk forward validation. Each and every, over here it is one by one, but in walk forward validation, it is multiple that you can have the window size. Okay. However, here we are going to do a train and test split, and we must deal with plurality of the data. These are the certain methods that we will apply: filtering, grouping, concatenation, bagging, multivariate analysis. All this thing we are going to see. So what I am going to do over here is all these are the different countries that we have. So many countries are there. I took for India, confirmed, deaths, and recovered from all of these. And then I have joined this to make it look like something like this. Okay, I've joined these things on left join and right join. All this, rename the columns because the column was named as 145 confirmed, 145 death, 130. I've renamed to confirmed, deaths, and recovered. I don't want these top 4 rows in my data set. So what I did is I started from the 4th row onwards, and all the rows I am taking. So this is what my data set is. So next one is we are getting into you means modeling part. Let's first see. This is my data set that it looks like for India. Okay, now I have one data set combined. I will reset the index. Right now index is this one. I'll reset the index over here to make the sequential ones, common sequential one that I'm having. Now, as I told you, your index should be in date and time format. So from pandas, I'm taking 2 date time to convert my index in this index column only to convert it over there. So this is what it's done. Splitting it now, if you want to see over here, India, this is how it looks like. It is in a pretty much good shape that I am seeing. Okay, split point int 70%. That's what I said. 70% of the total length. So from start till the 70% will go as train, and rest whatever means I gave a split point, and then 0 to split point it would be train. Rest would be from a split point till last would be my test data. This is what I'm having. This is the split point. A split point is 219 that I have. Okay, this is 70%. So in my train, I will have 219 data points. Rest will go to my test. So now we are going to do some visualization. So what I'm seeing is confirmed cases, train, test, and I'm seeing the deaths over here. So this is what you are seeing. This green line is the deaths one, and this is for test, this is for your train. So normal, just the basic that I'm seeing. Yeah, just the basic one that I'm seeing over here, that how to visualize it. Very simple. Since you converted your index into proper date time format, that's why you can see on x-axis. Otherwise, you won't see date over there. So now I was talking about resampling and resampling. Resampling could be of two types: upsampling and downsampling. Upsampling, what does it mean? Like I have daily data, I can combine it on a weekly basis. I can make it a weekly data, or I can make it a monthly data. That's what I'm doing. Resampling is equals to train.resample 7 days. Okay, 7D means 7 days weekly. I'm naming it and I'm doing it as a sum added, or you can take a mean also, but ideally it should be sum in this case. So I'm taking it. This is what it did. It created a weekly data. Same thing I am doing for monthly also, 1 month. So monthly data. Annually, you have to give, write A or Y over here. It would be annually. Down sampling is something now. It is, suppose it is a monthly data. You want to make it weekly. So what it will do, it will just give one place value, others would be 0, 0. So that's not considered correct. That's why down sampling is not used. So let's proceed further. So what I told you is that we will talk about decomposition. When you talk about any time series have basically two components, or the not two, basically two main components. One is definitely the error or the random component, which can't be explained. When we are talking about stock market, I think everyone would have seen the stock market graph. What is that? It comes up and down and something like that, right? So if you decompose it, if anything is having, basically there are three components. One is trend, seasonality, and then you have irregularity. If you see trend is the increasing or decreasing pattern in the time series, that with time it is increasing or decreasing. When we talk about seasonality is a repetitive pattern. Like in South India, you have this Ashadam sale, right? So why they give you discounts over there during this time frame? Because that is not considered to be auspicious moment to have any functions, and that's where they know that my sales are going to dip. What they will do is that they get out all these saris and everything for sale. Irregularity is something which is not part of trend and seasonality. It is randomness that you are having. That's the irregularity. There are two kinds of model, that is additive and multiplicative. Additive is your level, that is your normal thing. I mean, your time series, trend plus seasonality plus noise. If you add it up, it will give you this value. A multiplicative, if you multiply, it will give you. So what basically it means is, when we are decomposing it into multiplicative, I'll show you with this example. So what it shows is, this is your general series, okay? For confirmed cases, this is the trend. If you see, this is exponentially increasing, and this is seasonality, which is flat. There is no seasonality in the data. This is randomness. This is multiplicative. Since your trend is increasing exponentially, thus it becomes a multiplicative series. If it would have been a linear one, then it is an additive series. If you will do this on additive, it will give you not correct result. Thus, we know that this is a multiplicative series. Always this is a good practice, although I know all my data is numeric, but always this is a good practice to convert everything to numeric. When your continuous values, of course, convert it into numeric. So I'm converting everything into numeric over here, just to be on safe side, that there's no value which is my column is correctly having the data type. Now let's decompose the recovered one. Same you see on recovered one also. It is multiplicative, since I am having an exponential trend. Okay. Now there's very important thing which is known as stationarity of time series. Stationarity of time series is important to know when you are working on ARIMA model and its variant. Now, what is stationarity? Stationarity is a statistical property, basically, which tells you that mean, variance, autocorrelation, everything is constant. It means that there is no trend or seasonality in the data. Basically, when you don't have any trend in the data, then these tests, which is augmented Dickey-Fuller, known as ADF test, predefined hypothesis test, and KPSS test, only will tell your series to be stationary when there is no trend. Seasonality, they are not able to capture, but still, this is how we say, my series is stationary when I don't have trend or seasonality in my data. So quickly going over to that, guys, I'm from the stats model, you can get AD Fuller, and based on this, you what I'm doing, I'm doing the statistical hypothesis test. Null hypothesis is series has unit root 1, means series is stationary. Alternate hypothesis, sorry, series is non-stationary, and alternate hypothesis is that series is stationary. So if we fail to reject the null hypothesis, sorry, that's for KPSS. For ADF, it is that series is stationary, that is null hypothesis. Alternate says series is non-stationary. So if we fail to reject the null hypothesis, we are saying series is non-stationary. We always want series to be stationary. Thus, we have to accept, or we have to we have to accept the null hypothesis. There is no trend and seasonality, then it would be a straight line. No, there would be random component will still be there, so you will have some random noise. So this is what we did the test, and it says 0.98. It means I accept the null hypothesis and my series is stationary. Okay. You have another test also, that is KPSS test. Just it is opposite. Null hypothesis says the same thing. So you can even do this test. Any one of the tests you do, that's fine. You don't have to do two tests. Now, how to measure the time series? Mean square error, root mean square error, MAE, that is absolute mean absolute error, mean percentage error, MPE, mean absolute percentage error. In industry, we take this thing. But what is mean absolute percentage error? That is actual minus the predicted divided by the actual. Suppose your actual value is 0. This will not get any value. You will not get a correct value. At that point of time, you should measure mean absolute error or RMSE or MSE. As per the industry standard for MAPE, that is mean absolute percentage error, if your model has a MAPE value between 0 to 10%, it is considered as a good model. But greater than 10% till 20%, it is considered to be an average model, which needs to be improved. If it is greater than 20%, it is a worst model. You need to improve, otherwise you have to discard it. You can't consider that. Modeling time series, first is the naive approach. Naive approach is that I will take whatever is the previous value, I will use that one as the forecasted for my next one. Or you can also take the mean, the total mean of your series, and then I will say this is my forecasted value for the next time frame. Suppose my data is still 29th of November. So if I have to predict for 30th of November, I am taking a mean of my trained data and I am forecasting and I'm saying it is 30th of November will have the mean value. This is what I am doing. Simple prediction. Let's check the MSE and all this thing. This is what I am getting the MSE value. If you plot it, it will just give you a simple line because I'm taking the mean, and that mean I'm saying for all my time frame, this is what is there. This is actual test data, and for my complete test data, which is the predicted one, it will everywhere it is replacing as mean, which is not correct. So what we can do, enters over here, walk forward validation. That's where it will make the change. So what we are going to do is that I have created an empty list, confirmed value cases. I'm taking a mean of that. And what I will do, I will loop in one by one entry. I'm looping it for each and every confirmed cases, taking the mean, then adding it back, taking the mean, and then using it for the prediction, adding it back, and all this thing, which I explained you on top. So now if you see, let me show you this value. See, these values are differing, and this is increasing because now I'm inserting this. This is predicted. This is the mean for the train. Now this is predicted. It will go for my actual one in part of my training data. So now again, I will take the mean and then it will go. This is how it is doing the prediction, including one by one and doing the prediction. It is one step ahead prediction that I am doing. I'll take the root mean square. It is values would be high because my actual values are also high. Let's plot this thing. See, there is, it's not changing drastically, but yes, there is an increase. It's now no more a flat line. Okay, this is the naive method that I'm using. Now what I will do is that, this is the walk forward validation with your simple mean thing, average thing. Now I will use the naive method. Whatever is my previous value, that's what I'm going to use. Okay, that's what I'm saying. So with the general one, it comes something like this. You will just see one line. See, this is the one line. Whatever is your last value on your training or in your test one, that's what it is taking over here. Now I'm getting the walk forward validation. So each and every value, I'm not calculating any mean or anything. This value of test it will be considered now for training, completing whichever is the last value, it will be considered like that, each and every value. So it means the original one I am adding directly over here, nothing else I am doing. So if you see now, see, this line is completely overlapping. Okay, that means for the training one that you have, it is not for the test data. And remember, this is the sequence that we have split the data into, Mish. Okay, so of course, with training, the time frame with test, it is increasing only. So whatever is the mean, that is lower than your test one. Okay, auto correlation and partial auto correlation. So auto correlation is basically we have lag variables. We will just shift one position that goes as the lag variable, lag 0, 1, 2, and so on. So what we have is, if we are taking the difference twice, I am differencing it. Just assume this thing for your explanation. I am doing this thing. This is your bound, the confidence interval. How many lines are within this blue level? That would be your, it is auto correlation, ACF plot. So your Q value in ARIMA. So one value is out of this, so Q will go as 1 because next one is within this. So this one is also out, but immediate before this next one, suppose there would have been one more line, then Q will become 2. Okay, this is autocorrelation. Same way you will read for partial autocorrelation. Partial autocorrelations removes the impact of the intermediate lag, like between lag 0 and lag 2. It will remove lag 1, then it will understand what's the relationship, correlation between, or autocorrelation between lag 0 and lag 2. That's what partial do. So 1, 2, 3, 4, 5. 5 is the value over here since next one is within this. Okay. So partial auto correlation will generally be high. Now let's get into ARIMA model. So ARIMA will have 3 values, P, D, Q. P tells you partial auto correlation, D tells you differencing, Q tells you partial, auto correlation. Q tells you auto correlation, ACF, PACF, and this is differencing. Differencing is to that stationary one. If it is not stationary, you will difference it again, check it to make it stationary. So let's say these are the values that I am, and since I have the seasonality, so I'm taking the capital PDQ also for the seasonality window. It is also partial auto correlation for the seasonality, and I am taking the seasonality for the week. So 7 is the size over here, fitting the model, and the model is done. This is the statistical model that you get. All these lags and everything is relevant that you are seeing. 0, 0, 0, all should be considered. Okay, so now you have AIC, BIC, HQIC, all this thing. That's what I have written. You guys can go ahead and read this. Interest of time, I don't have time to go over these things, but just one thing, AIC, lower the value of AIC, better is your model. What is need of doing walk forward validation? It just takes the value of the test data. That's not just for the test data. If you are doing for train also, you can do this, but you are taking one that I was doing for naive method. I can do this on ARIMA also. I can do it on SARIMA also. All these I can use walk forward. So one, it is training in multiple iteration your model. So now I will predict it on my data, complete test data. I'm doing the prediction. This is how it looks like on my ARIMA model, on my SARIMA model, basically. Okay, it is slightly deviating, but not that much as compared to your naive or your moving average or your average method. Now, one thing, guys, over here, this is all ARIMA. This is, let me show you this one. Okay, I'm using a SERIMAX model over here. Okay, what is the SERIMAX model? SERIMAX X means that I am going to use exogenous variable over here. Okay, what is my exogenous variable? Okay, SERIMAX, all these things you guys know. I'm just forecasting it for further, predicting it and storing it. So I'm skipping this. I'll come to the SERIMAX part. So this is with walk forward validation that I did. And with walk forward validation, if you see, this is overlapping exactly. And that's where you will have somewhere or the other overfitting problem with walk forward. If you are taking one point, if you are increasing the window, that will reduce. But still, this is one of the method that we use. Now, variations in ARIMA, there are certain variations. Something which you should study about is fractional ARIMA also. This you can give it a read. I will talk about auto ARIMA first, then I will go to Arimax. Auto ARIMA in your basic time series that is not handled. So you can install a library which is known as PMD ARIMA. This is better than auto ARIMA. What you would have learned in your time series module is that we will give a range and we will do a for loop multiple times and all those things. Instead of this, in one go, you can do auto ARIMA where I'm giving the start P as 1, D I'm giving as 1. Just for your understanding, I did this thing. I don't want any start or stop for this one. I know only one differencing is required and I will give in this. Start Q again 1, max P. How many max values of P means what is the range that in for loop you will give 1 to 0. Same thing I am giving for capital P, D, Q and all these things. Seasonality true, stationality false, because I don't want to do, I have given D is equals to 1. M seasonal, that is month thing, and all these things. Information criteria, how to decide based on BIC. Alpha is 0.05, trace is equals to 0 so that I can print it. Now I am doing this thing. It will automatically create so many things. So what you have learned in your time series to create multiple loops, 2 or 3, total 4 loops that you would be creating for ARIMA, you don't need to do with PMD ARIMA. In one go, all the things would be done. Done. My model told me this is the best one. Pick it up. I am picking it up over here. Okay, now with that, I got everything out. So just in 2 lines of code, I was able to create a beautiful ARIMA model over here. Predicted for next 94 pointers, that is your test. And I'm going to do this thing. This is my prediction. If you see, there's a slight deviation, but it is beautiful. Okay. Is it? Yes, it is looking for the lower. What I give AIC or I give BIC? Just let me check. I give BIC. Yes, it will look for lower BIC, but AIC, BIC, both you can give. Means you can give any one of them. Generally, when your AIC is lower, your BIC will also be lower. Go ahead and read this thing on your the HQIC and OOB also, out of bag validation scoring and all this thing. But you can give AIC, BIC, anything. Okay. So this is the prediction that I have. Now there are so many variants of ARIMA. I'm checking the correlation also. This is the Pearson correlation that I have written about. So you guys can go ahead and read how death is, how confirmed is related with death, confirmed is related with the recovered. This is what I'm showing you, that this is the correlation. It is quite related. You are getting a straight line, which is quite evident, but still you can have this Pearson R correlation. Simple your Pearson correlation, that's what I'm checking. And this is the correlation value. Both are highly correlated. Approximately they are equal only. So these are again your correlation only. Now I'm coming with the exogenous part. What is exogenous? Exogenous is something, is a variable which you're not considering as a part of a data set. Means which you don't want to forecast, which is something which you don't want to forecast. Over here, since my confirmed cases is related with recovered, so what I'm taking is I'm taking exogenous variable as recovered. I want to take, or ideally it should be done that recovered based on confirmed, but overall, just to explain you, since we were doing confirmed, I am just taking recovered over here. So what is the impact of recovered on my confirmed cases? That is what I'm going to, I'm not going to predict recovered. It is still univariate. By with the help of exogenous variable recovered, I'm trying to do the forecasting. Okay, this is what I got. Now, if what I am going to do is that use the previous value of recovered cases to model the confirmed cases of the next day, because I don't have an input for exogenous variables. It works like your machine learning model only. I need an input to predict for the next day or next time frame. So I'm just taking whatever is the previous value, I'm putting it as my recovered cases value for the ones that I have to forecast confirmed cases on. So it behaves something like your machine learning only. You need to have value for your exogenous variable based on which you are going to predict for your dependent variable. Okay, on the entire data set, test data set, I'm going to do the prediction. Same exogenous is recovered. Now, This is my error, do the forecasting, prediction, and all these things. You are able to see that it has improved. The difference has improved over there. Your MSE has reduced. That's the impact. If you include deaths also over here, it will improve further. It might improve further. So you have to see those things. Now, what I'm doing, see over here, what I'm doing is I'm going to make a complete perform out of sample prediction using walk forward validation, means the sample which I have kept separately. That's what I'm going to do over here. Again, I'm doing exogenous as Y. You can give it, create a list over here and pass it to exogenous. That will also work. Okay, it will take some time to run. Fine. So add a just adding a column in my test data, which will show the Sarimax output with this walk forward validation thing. So it will take some time to run because you have huge data set, and for each one it is doing walk forward validation. Meanwhile, I'll proceed with some of the theories. Let it complete. You will see with walk forward validation, you are able to predict something very similar on the same lines. Generally, this is not when you are training a model. Yes, you can go with walk forward validation, but ultimately you have to see every time we are doing walk forward validation, it is overlapping, means it is a perfect model, but actually it is not. It is a overfit model that I am creating over here. So that's not really appreciated. You should take a huge, you should take some window for walk forward validation and do it. It would make sense. There is another variant also quite used in industry for the ARIMA, which is known as VAR, vector autoregressive, or it would VERMA model or very max model that you have. This is the one which is quite evidently used in industry. I have given a read on this. Please go ahead and read this. You can practice it also from here. Okay, exponential smoothing. You guys pretty much know this one. It doesn't take into account the auto correlation. Auto correlation, basically what we have seen means that the current value is related to the previous value of its own. That is auto correlation. So I'm doing exponential smoothing, considering it as additive. Damped is equals to true, so that seasonality also comes into picture. And then this is the prediction that it is doing on exponential smoothing. Okay, this is your basically, since this is trend, so it is able to do this thing. When you don't have any seasonality, when you have seasonality, SES won't give you a good output, then you should use false winter method. That is triple exponential smoothing. I'm doing walk forward validation on the same thing. If you will see this thing again, line, okay, yeah, line, if you see, approximately it is overlapping. This one. Now here comes the important part. Multiple ahead prediction technique. This is recursive prediction technique. You have over here, you have recursive model with error adjustment. You have direct technique. You have MIMO method, Didimo method. So many are there. Then you have direct method. All this you can read along, but this is better than your walk forward, as multiple time frame you are predicting in future, using it back again to predict the future for that time frame. That's what I am doing, multiple ahead prediction. Okay, so see, for all this, it is, these are so many prediction that is done. Now again, it will use this as input. It will create the new steps for me. So this is what it is doing. Step size is 7. 7 I'm using to predict. Walk forward is only for 1. Over here, I have used walk forward for 1. I didn't use that rolling window thing. Over here, I'm doing for multiple time frame. Okay, so like that, it is predicting for me. Now it's just to reshape my data. And if you see this prediction with the 7 steps also, it is overlapping, but it is better. Slight deviation you might see, but it is better. Now I have 7 steps ahead, not just 1 step. 7, it is 7 days ahead. I'm doing the prediction, including it over there in one go. Then again doing 7 steps prediction, including it in one go, not one by one, because one by one with that, what happens? The one value for which you are predicting, that value is Approximate means that would always be a good forecast. As you will increase in time, your forecast accuracy will reduce. So if I'm having 7, the 7th one will have the reduced accuracy, but that's what I have to do. So I'm using it on an extended one. You can use 10, 12, whatever you want, but larger you go, your deviation would increase. Okay. Okay, this is for Halls. This is for your SES also. Exponential smoothing, that's what I'm seeing over here. If you see, there is slight deviation. Sorry, I didn't run this. If you see, there is a deviation, although your walk for, and this is 30 step ahead. That's what I was saying, that when you increase your step size, you will see the deviation has increased. But always multiple step ahead prediction is considered to be good compared to your single step ahead prediction. Now I'm coming to multi-layer perceptron. Till now, I was talking about all these data sets that you are having, models, that is statistical model. I'll show you multi-layer perceptron, then we will do, then I'll show you a glimpse of multivariate analysis also. Okay, one here, guys, remember your exponential smoothing doesn't come with exogenous variable. You can't use it for exogenous variable. Thus, if you have any exogenous variable, you have to rely on variance of ARIMA in statistical modeling or in time series statistical models. Otherwise, you can go with neural net or any other regression model. Recently, the project that I did, I created random forest regressor and which one was that? The XGBoost regressor for my modeling, and that's what went into production also. You can learn about statistical versus machine learning models over here. So multi-layer perceptron, it is like your artificial neural net only. Okay, what is the additive, multiplicative, and trend? In Holzminter, we see trend as additive or multiplicative. So it's one of them, although it is multiplicative, but just to show you that you can give a value additive over there also, I have given additive, but your series is multiplicative. Since your seasonality is not over here, thus multiplicative won't make much difference for you, but still your trend is exponential, you should go with multiplicative only. Okay, so I have put some variants just to explain you the case study, that what are the different things you can give. So this is something on your ANN. You guys pretty much know. I'm not going into this MLP and all that multi-level perceptron explanation. Who don't know, quite a good amount of readout material is over here. You can do this thing. Now, what I'm going to do is that when you are working on any machine learning model compared to your time series, the very first thing that you need to do is that it range. You need to create sequence over there. So I created a sequence named as T1, T2, T3, and all this thing. Instead of dates, I will be using this sequence. So now if you see samples, see, this is what I'm getting, T1, T2, T3. For confirmed cases like that, it would be, you won't be able to work on the sequence. I'll convert this thing also. So I'm creating a converting time series sequence to samples. First one. So now this is, I'm using the sequential model from Keras, and layers would be dense over here. Activation function is ReLU, and optimizer is Adam. Loss I'm measuring on MSE. Verbose is equals to true. All this epochs and all this thing came up. Let's optimize the MLP. Look back period, how much I want, number of layers, what nodes you want, activation function, optimizer, all these things that you have. So same thing on the same sample thing that I am having over here. This is the sequence that I created for each and every value. So I'm converting the test sequence also into samples, and then I'm doing the prediction. This is what I got. All the prediction value, adding it over here. So now you have different models prediction value for your confirmed cases. With walk forward, this is your normal prediction with that mean. This is with walk forward validation. This is your prediction on naive model. This is with walk forward and all these things. This is with your perceptron, that MLP that you are having. Now, This is simply matrix. If you will see how well it has performed, how well your MLP has performed without any walk forward or anything, this is how this model has performed. Best model till now. Adding more variables if you want in MLP, there are two methods to use it. If you wanted to do exogenous variable, that is known as multiple input series. If you want to do, if you want to have multiple multivariate analysis or multivariate prediction, then it is known as multiple parallel series. Okay, so this is first I am doing multiple input series over here. That's what is for exogenous. Again, this code block, you guys can go ahead. I'm using n steps prediction over here. Sequence which I created T1, T2 and all that. What is the n step value that I want? This is the length of my test or train data, whatever you are defining as your step size, which you want to predict. And then each and every part I've written, find the end of this pattern. Where is the, what is the step size that you have? Check if we are beyond the data set, whether it is within the length or not. Gather the input. If it is so, then break it. Gather input and output patterns. Your X and Y, that is your input and output that you are having. Append it over there. And this is the function that I created. Now, when I'm just moving, it is like a lag variable that I'm creating over here. T1, T2, T3, like that. Now, train dot drop NA. So train dot, because when you're shifting it, it will shift one position. So you will have some NA value. So that's what I have dropped it. Recovered, confirmed, T1 cases and confirmed. These are the values that I'm taking, not just one variable, I'm taking recovered also along with this. This is multiple input, the exogenous. You don't have term exogenous explicitly over here, but recovered is working as an exogenous over here. That's what I'm going to do the prediction. This is what I created. Now using your ReLU, Adam and all these things, you are getting the prediction, epochs, running it multiple iterations, then predicting on my test data. Again, same thing. On recovered, I give, and based on that, I'm doing my prediction. Okay. Now, this is your simple Y have RMSE and all. Now, if you see with this one, with predicted confirmed cases with your recovered one with exogenous as recovered, this is the difference that you are having. This is the series that is predicting. It is also equivalent to the previous one that we got. Why? Because they are highly correlated. Now, multiple layer, this is your multivariate analysis or multivariate prediction that I'm going to do. I have not given confirm T-1 and given over here. This is multiple parallel processing, converting train sequence with multiple variables. For both the variables, I'm converting it into multiple series, recovered and confirmed both, and then I will do the prediction for both recovered and confirmed. So if you see over here, multiple parallel series, what happened? This now. Okay, something might be that I have not run it. That's why, yeah, I didn't run the previous one. That's why. So now it is predicting for both. See, it is doing this thing, prediction for both my recovered and confirmed together. And this is the mean squared value that you are getting for your recovered. This is for confirmed cases. If you want to visualize the test data, this is your recovered, blue line. This is below, this blue line below this is your test recovered, and then you have predicted recovered, same whatever you have as the test. This is your confirmed cases, green one, and prediction is this red one, which it is predicting higher. Good. If it is predicting higher also, we would be much more working on this and taking action on that. So this is multivariate that I did using MLP method that we did with exogenous, where you won't be explicitly saying it is exogenous. I just give recovered over there. Over here, what I'm giving is I'm predicting for recovered and confirmed together. So I created sequence for both of them and then doing the prediction in MLP. Multi-step prediction in MLP, this is known as MIMO, which I told previously also. Now I'm doing multi-step ahead prediction in MIMO. Same thing, which I explained previously, but in MLP, same way I'm doing over here. No walk forward, nothing I did. Directly I am doing multi-step prediction. For confirmed cases only, for univariate only, I'm showing you this. For what happened? For univariate only, I'm showing you this thing, this multi-step ahead prediction that it is showing. I created 3 sequence, T1, T2, T3. So for all the lag variables, I'm doing this thing, and this is what is the error. Now, if you see the prediction, this is how it is showing you. For my lag 0, that is my original, this is blue line. Then this yellow line is lag 1, it is near to the blue line. Lag 2 is the red one, which is slightly above the yellow line, and lag 3 is the green one, which is more above to this one, because you are departing the values from the actual one. So even you can do multi-step prediction for univariate and multivariate also, same way you can do. Just you have to use the same thing and use it with this code piece. So bias is what? Like just take a simple example. You know a person X, or you have a experience with a person named X, and with that your experience, you met 3 people, okay, and 3 people are not good for you. They somebody cheated on you in terms of money, or somebody backstabbed you, or something or the other. Now you are very afraid of those person named as X, okay, any person who is named as X. So what is there? You are creating a biasness for the whole society. Now you don't want to be friends with that. That's what is the biasness when we talk about data also. My model is only able to learn highly, means whatever pattern it is getting, it is able to learn from my training data so well that has become biased, that if anything comes as an alien data set, which is your test or the future value, you don't like to, you won't entertain it, you won't be able to make a correct judgment on that. That's what is biasness, that's what is overfitting. Okay, now comes your variance. Variance is just opposite of that. It is very loose. Okay, I will make friends with everyone, I'm good with everyone. That's the problem of underfitting that you are doing. These are just different terminologies. When in interview you get these kind of question about bias and variance trade-off, explain it with this simple example. This question will do wonders. Okay, this answer will do wonders for you. Explain with this simple example. You don't need to get into complications over there. Now, this, if you see, this is high variance. Okay, I'm having high variance. This is the biasness that I created. I don't want anybody to enter over here. This is everybody I want to have a friend. Low bias and low variance. This is a good balance, but how to attain that? For that, this is known as actually Goldilocks zone, the sweet spot between the complexity and increase of bias, and flexibility and increase of variance. Generalization is a balancing act where you shift between models with high bias and high variance. So this is hit and trial, but that is known as Goldilocks zone. Many people don't know this terminology. Again, guys, this is something expected from you when you go for interview. So what is the conclusion? Confirmed, recovered, and fatality seem to be linearly correlated, we saw. Adding exogenous variable for forecasting of confirmed cases along with walk-forward validation gave a more appropriate result. Traditional statistical models rely on linear relationship to find structure in data and work well on univariate data, but may not work very well on multivariate. Using MLP is easy to do a multivariate prediction. That's what we saw. Comparison on various models. Naive model, generally you will use as the benchmark model, and a statistical model suitable for univariate time series and small data sets. Capture linear trends, ARIMA family and exponential smoothing family that you have. So in ARIMA itself, you have around 10 different variants, ARIMA, SARIMA, VAR, and all that.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notifications bell, so that you don't miss out on any new updates or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing. So make sure you share this video with your friends and colleagues. Make sure to comment on the video with any queries or suggestions, and I will respond to your comments.